Now let's discuss glutamate receptors. There are several types, including the neuronal, IAT, and the vesicular, V-glut. Now there are at least 8 subtypes of metabotropic glutamate receptors organized into 3 separate groups. Now group 2 and group 3 receptors can occur presynaptically and thus function as autoreceptors to block glutamate release. And thus the drugs that stimulate these presynaptic autoreceptors acts as agonist and may therefore reduce glutamate release, and thus are potentially useful as anticonvulsants and mood stabilizers, and may also protect against glutamate excitotoxicity. Now let's discuss group 1 metabotropic glutamate receptors. Now these are mainly located postsynaptically, where they hypothetically interact with other postsynaptic glutamate receptors, mainly to facilitate and strengthen responses mediated by ligand-gated ion channel receptors for glutamate during excitatory glutaminergic neurotransmission. Now the main receptors for glutamate are NMDA, AMPA, and kainate. These are named after the agonists that selectively bind to them and are all members of the ligand-gated ion channel family of receptors. They tend to be postsynaptic and work together to modulate excitatory postsynaptic neurotransmission. Especially AMPA and kainate receptors may mediate fast excitatory neurotransmission, allowing sodium to enter the neuron to depolarize it. The NMDA receptors in the resting state are normally blocked by magnesium, which plugs the calcium channel. Now these NMDA receptors are interesting as they function as a coincident detector that can open to let calcium into neuron to trigger postsynaptic actions from glutamate neurotransmission only when 3 things occur at the same time. And these are: first, the glutamate occupying the binding site on NMDA receptor; second, glycine or d-serine occupying its site on NMDA receptor; and the third, depolarization occurring allowing magnesium plug to be removed. Interestingly, many important signals by NMDA receptors that are activated when NMDA calcium channel are open include long-term potentiation and synaptic plasticity.